All right, today we're solving inequalities involving absolute value. The first thing we're going to do with each of these statements is branch it into lose the absolute value, set it equal to the positive of k, and then set it equal to the opposite, the negative of k. And when we set it equal to the negative of k, notice it's the opposite sign. We have to flip that inequality. We're going to do the same thing with x. The absolute value of x is greater than k. Set it equal greater than k. And then because I'm taking the opposite of k, I have to flip the inequality. Now what you're going to notice, you guys, is that when the less than is touching the absolute value, it's going to be an and statement. So you will notice that when this less than is touching the absolute value, it is an and statement. And when the greater than is touching the absolute value, it will always, always, always be a or statement. Okay? Now I have special sayings for these that will remind you. Less than means when you see a less than is in the okay. So less than, and for this great or, when greater is touching the absolute value, we say great or. It's an or, great or. Everybody say great or. Great or. Less than. Okay, questions? Now, we're going to go on to, and we're going to break this up. Is this an and or an or statement? Why? Because it's less than, like Vanna White says. Okay? So this is an and statement, and I have to set it equal to the positive. And then what do I do over here? Is this an and or an or? Who said or? Is this an and or an or statement? And. But what am I going to do to this inequality here? Ariana, what's this one going to be?
It's going to be x is greater than -5.
Right, because I set it equal to -5, it's going to be, because I set it equal to -5, I have to flip that inequality direction. And then I graph it. You can or you don't have to write the in-between. It's not necessarily a necessity. Okay, now I'm starting at the -5, and is usually one line or two. One line, right? We're looking for the intersection, generally speaking. So I start at the -5, and it's an intersection. It's only these numbers in between, those two sets. Now, I'm going to go over here, and I'm going to set it equal to the positive. And then remember, notice this time, instead of less than, it's greater than. Is that an and or an or statement? Or, great or. Okay, and then what's the next one going to look like, Caleb?
X is less than -5.
Less than, so he turns the direction of the inequality and sets it less than -5. And now I'm going to put it on the number line. Okay, and I graph it. Usually or statements are 1 or 2 lines. Two. And that looks about right. Life is good when we are finding the absolute value and comparing it to a positive number. So, bigger story here, other than this in particular one, is that we're really looking for the absolute value of a number that's less than a positive number and the absolute value of a number that's greater than a positive number. This will be the likely scenario. All right, now let's look at a situation where we're looking for what is the value of an absolute value, what is the absolute value of a number less than -2. So we do the same thing. We branch it into two parts. X is less than or equal to -2, and X is, now, is this an and or an or? And then I set it equal to the opposite of -2. What's the opposite, Julian, of -2? Good. And now we've got X is less than or equal to -2. I'm now putting this on the number line. X is less than -2. Solid line moving to the left. X is less than is greater than +2. Is this an intersection or a union?
Intersection.
Who says union? Okay, what makes us say this is a union? McRitchie? Okay, that's what it shows in the graph, but there's also something here. What does and mean? Yes?
It is an intersection.
It's an intersection. So this should be an intersection. It's a conjunction. When you see the term and, it's an intersection. Where is the intersection on the graph? Where's the intersection on the graph, Chris? There's no intersection. So what would we say?
Empty set.
Empty set, no solution. I gave you 4 different ways. You know, the braces with nothing in it, the null sign, or null set. Nicole?
Why did you switch this sign?
Because when I take this opposite number every time, since I'm taking the opposite here, opposite sign here, I have to take the opposite sign here. Every time on that second branch. It's always going to happen no matter what. So Nicole, why don't you branch off for me number 4? What's it going to read? Is this an and or an or statement? In an or, should there be 1 or 2 lines? 2. Okay. So now it's a conjunction or disjunction? Conjunction, disjunction. Disjunction. Don't be afraid of those words. Say them every time to yourself. So Nicole, how would I break that up?
One of them would be X is greater than or equal to -2.
Good.
And the other one X.
And it's going to have an and or an or. Nicole? Or. And then what's the other one going to be?
X is less than or equal to 2.
Perfect. And now I'm going to draw it. X is greater than -2. Boom. X is less than 2. Boom. Now, and a union means I'm having this private party at this very exclusive club. And at the club, I'm inviting 2 groups. I'm inviting the red group. No, let's go how about the green group? And I am inviting the yellow group. Okay? The yellow group is this one right here. Okay? The green group is this one right here. What does it mean to be a union? Who's invited? Who gets to walk up to that door at the nightclub and get in at the front of the line? Chris?
All real numbers, so everybody.
Everybody, the green group, anyone in the green group can walk up to the front door and say, VIP, let me in. Anybody in the yellow group can walk in and say, VIP, let me in. Either or. Everyone's invited. And so that means our solution in this case would be all real numbers, like Chris said. Okay? Now, let's go back really quick and look at really the bigger picture of these is that here I'm saying when I have absolute value that's less than a positive number, this is what it's generally going to look like. Where it starts and ends may be different. When absolute value is greater than a positive number, this is generally what it's going to look like. Okay? But when absolute value is less than a negative number, let's make sense of this. This is the most important part. What number, you guys, would fit in this absolute value and make the number be less than negative 2? What number could we plug in there? Let's find an example. Ian?
Negative 4.
Negative 4. So if I put negative 4 inside there and then I take the absolute value, what's the value of it?
4.
So any negative number I put in there is going to eventually become positive because of that absolute value. Will a positive number ever be less than negative 2?
No.
And that's why there's no solution. Does that make sense? Now let's look at this. Negative or positive? If I put a negative number, negative 4. When I take the absolute value, what's it going to be?
Positive.
So no matter what negative number, it's always going to be bigger than negative 2 because over here it's going to end up always being positive. Is that making sense? Okay, so that's why it's any real number, any negative, any positive. Once I take the absolute value, it's always going to be bigger than that negative number. Okay, now, solving. Branch it out, same thing. Notice, less than is touching, so it's an and statement. Is this a conjunction or disjunction?
Conjunction.
Conjunction. Is it, and so it's an intersection or a union?
It's a
Conjunction.
intersection.
It's an intersection. I'm going to add 5 to both sides. I'm going to add 5 to both sides. And an intersection should be one line starting at the 2, not including 2, up to 8, but not including 8. Okay, you should be taking these notes. Oops. All right, so this one, is this an and or an or statement? Or should the answer on the graph be 2 lines or 1 line?
2 lines.
Generally speaking, because it's a positive answer, it should be 2 lines. We're going to do the same thing. We branch out. Every time, are we noticing when I set it equal to the negative, like Nicole asked earlier, I switch the inequality sign. You with me? When I set it equal to the negative, I switch the inequality sign. So instead of greater than or equal to, it's going to be then less than or equal to for that negative 9. And then we solve, and then we graph. And as we said, when absolute value is greater, it's a union. It should be 2 lines. Okay, questions here? Okay, one more question. If the bell rings, I need you to stick through this. There's one more problem. Can I move on? Okay, they're going to start to get complicated. Before you do anything, before you branch, you must isolate the absolute value. Think of that like it is a variable. We isolate the absolute value. So what would we do first? gyrus. Add 6. Now, what kind of problem is this right now? Is it an and or an or? Is it a conjunction, disjunction? Is it a intersection, union? Saffron?
It's an and.
It's an and. It's an intersection. Okay? It's a conjunction. So I add 6, like Jairus said. Now, here's why we have to isolate our absolute value. This is the point where potentially it could switch from an intersection to a union. When would that happen? When would that happen? David? Yeah, if the coefficient of that absolute value was a negative, right? If there was a negative here, as soon as I divide by negative, don't write this down. -2, it flips my inequality. Now it's a union, and then I branch. Once I get that, okay? Now, for you guys, even the PowerPoint didn't say to do that. Now we're going to divide both sides by +2. It doesn't switch, but that's the situation. We can't define whether it is a conjunction or disjunction till the absolute value is alone. And then we branch it. And graph it. All right. That's it.